Assalamualaikum warahmatullahi wabarakatuh and good day everyone. In this video, we are going to learn about Poisson distribution. Okay, Poisson distribution is used to model situation where random x, variable x, is the number of occurrence of a particular event over a given period of time. So the keyword here, you must have the interval, time or space. Okay, the number of occurrences is a discrete random variable. The occurrences are random, and then they are also independent. The notation will be x distribute p naught lambda. The parameter is lambda. The formula will be px equals to x e to the power of negative lambda, lambda to the power of x over x factorial, where x is number of occurrences, lambda is the mean or equals to expected value or average. E approximately 2.71828, or you can simply press on your calculator. To find probability for Poisson distribution, we have two ways. The first way, we are going to use the formula only for notation equal, and then we are going to use the table. The notation is greater than equal. This one is an example of table. Okay, in this distribution, we are going to find the mean, which the mean is equivalent to the lambda. Variance also equal to lambda. Standard deviation will be square root of lambda. Okay, example 6, we are going to find the probability using the formula x distribute p naught equals to 3.5. The lambda here is 3.5. So question A, px equals to 2 equals to e to the power of negative lambda, or lambda is 3.5, e to the power of negative lambda, lambda to the power of x divided by x factorial. Zero 0.1850. Question B, probability of x less than 2. So remember, our x start with 0, so less than 2 exclude 2 means px equals to 0 plus px equals to 1. So we are going to substitute into the formula e to the power of negative 3.5 to the power of 2 divided by 0 factorial plus e to the power of negative 3.5 to the power of, sorry, this one is to the power of 0, 3.5 to the power of 1 divided by 1 factorial, which is equals to 0.1359. Question C, probability of x greater than or equals to 2. Since we do not have the number of sample, so we did not know greater than or equals to 2 up until what number. So we are going to take total value of probability will be 1 minus probability of x less than 2, exclude 2. So we have from the previous question 1 minus 0.1359, which is equals to 0.8641. Example 7, we are going to use the table. Must remember that the notation inside the table is greater than equal. Greater than equal. Example 7, we have x distribute P0 where our lambda is 5.7. So only in Poisson, we have only one parameter, which is lambda 5.7. Okay, we are going to look for lambda 5.7 in the table. Okay, from the table here, we have our lambda is 5.7. Okay, now the first question, you must remember that in table, the notation is greater than or equal. So look at question A. The notation is already in greater than or equal. So our R equals to 3. So R equals to 3 will be here. And the probability will be 0.9232. Okay, question B. Question B, the notation is greater than 3, means we are going to look at probability of x greater than or equals to 4. Our R equals to 4, the probability will be 0.8200. Question C, probability x less than or equals to 3. So less than, we are going to minus 1 minus probability of x greater than or equals to. So we are going to reject 4, not 3. So we are going to have 1 minus 0.8200. The answer will be 0.1800. Question D, less than. So still we are going to 1 minus probability of x greater than or equal. Since 3 is not included, we are going to reject 3. So our working will be 1 minus 0.9232. 0.70768. Question E, probability x equals to 3. So we are going to look at probability x greater than or equals to 3 minus after the number 3. Probability x greater than or equals to 4. So 3, here we have 0.9232 minus 0.8200. 0.1032. Okay, question F, probability of x between 2 and 5, include 2, exclude 5. So we draw a number line. So we have 2 and we have 5. Okay, make sure we do not want 5. So we are going to count up until 4 only. So the question need for the 2 until 4 only. Okay, 2 until 4 only. So the notation for the table is greater than equal. So we are going to subtract. Okay, from the table, we have greater than or equals to 2. We need 2 until 4, and then we are going to subtract or reject 5 and above. So this region we are going to eliminate. So our working will be probability of x greater than or equals to 2 minus probability of x greater than or equals to 5. Okay, now refer the table. Greater than or equals to 2, r equals to 2, the probability will be 0.9776 minus r equals to 5, 0.6728. 0.3048. Question G. X between 2 and 5 include 5 exclude 2. So include 5 exclude 2 means we are going to start at 3, 4 and 5 at 3. Okay, we are going to exclude 2, so we take 3. Probability of x greater than or equals to 3 minus probability of x greater than or equals to. Okay, now we are going to reject 5. We have equal sign, so we need 5. Then we are going to reject 6. Okay, then from table we have probability r equals to 3 is 0.9232, and then we are going to subtract r equals to 6, 0.5050. So will be 0.4182. Okay, question H. 2 and 5 both are included. Okay, now we look at, we want 2, so we are going to take 2. Probability of x greater than or equals to 2. Okay, we also need 5, and then we are going to reject 6. One number after 5. Sorry, it's 6, not 7. It's 6. Okay, x greater than or equals to 2 is 0.9776 minus 0.5050. The answer will be 0.4726. Example 8. The number of telephone calls made to a switchboard daily has a Poisson distribution with mean of 8 calls in every 5 minutes. Okay, so here very clear, this one is a Poisson distribution. Then we are going to write the distribution. We let x be the distribution of calls made to a switchboard in every 5 minutes. Okay, so P note, the lambda, the mean, the expected, the average. So this one is the keyword. Okay, keyword, the mean is 8 calls, so our lambda is 8, and then the range will be 5 minutes. Okay, now we look at the question. Okay, given the distribution, the mean is 8 for 5 minutes. So we look at the question. Find the probability that in the next 5 minutes. So the question also 5 minutes. So we are going to use lambda 8. Okay, this one you're going to find on your own. I'm going to change the sentence into mathematics equation or notation. Okay, the first one, no call. So we are going to find probability of x equals to 0. You can use the formula or the table. Question B, 5 calls. Probability of x equals to 5. Question C, at least 3 calls. Probability of x greater than or equals to 3. Question D, less than 4 calls are made. So probability x less than 4. Question E, between 3 and 5 inclusive. Probability x between means inclusive, we are going to include both 3 and 5. Okay, for question 9, the number of breakdowns in a particular machine occur at rate of 2.5 per month. Assuming that the number of breakdown is following Poisson distribution, find the probability that more than 3 occur in a particular month, less than 10 breakdown occur in 3 months period, exactly 3 breakdown occur in 2 months. Okay, first, for the first question, we have for a month. For question B, we have 3 months period. For question C, we have 2 months period. Okay, for this question, we are going to change the lambda. Given lambda 2.5 is per month, only 1 month is 2.5. So question A is 1 month, A is 1. Question A, the distribution is Poisson, the lambda is 2.5. The question is more than 3. So probability X more than 3. Okay, for question B, the period is 3 months. And then we are going to change the lambda. Our new lambda is 2.5 multiplied by 3. 7.5. Okay, we are going to change the distribution. So y, we let y will be the new distribution. The lambda is 7.5. And then the question less than 10. Probability of x less than 10. Question C, 2 months. Okay, we are going to change the lambda. Lambda is 2.5 multiplied by 2, which is equals to 5. So our distribution, the new distribution, let's see. A, distribution A, the lambda is 5. The question is exactly 3. So Px equals to 3. Example 10. Cars arrive at petrol station at an average rate 30 per hour. Assuming that the number of cars arriving at the petrol station follows a Poisson distribution, find the probability that. Okay, now our lambda is 30 only per hour. 1 hour, the lambda is 30. So the first question, question A, question B, the interval is 5 minutes. So we are going to change the lambda. Okay, for question A, we are going to change the lambda. So here is lambda equals to 30. This one for 60 minutes. Okay, so for the question A and B, we are going to find for the 5 minutes. So P0 is lambda. So how to find lambda? Lambda is equals to 30 lambda for 60 minutes. So 30 lambda divided by 60 multiplied by 5. So our lambda will be 2.5. For question A, we are going to use lambda is 2.5. So lambda is 2.5. No cars. So Px equals to 0. Question B. More than 3. Px greater than 3. Okay, next. For question C, we have 15 minutes. Question C, we are going to find a new lambda. 30 lambda divided by 60 minutes multiplied by 15 minutes. So the new lambda, we let y distribute Poisson, and then the lambda is 7.5. The question is more than 5. So probability X greater than 5. Question D and question E. Question D and question E. In question D, half an hour is equivalent to 30 minutes. So we are going to find the lambda. 30 divided by 60 multiply by 3. Multiply by 30. So our new lambda for question D. Let's say A Poisson, the new lambda is 15. And then the question is 10 arrives, will be probability of X equals to 10. Okay, question E. Question E, the interval is 10 minutes. So we are going to change the lambda. Lambda equals to 30 over 60 multiplied by 10. So lambda will be, say B, note 5. So the question less than 3, probability of X less than 3. So make sure you find all the probability for the question number 8, 9 and 10. So that's all. Thank you. Bye bye.